So I know fractions aren't everyone's favorite thing, but inevitably in math, you're going to see fractions. So if I see this 1/2 times 3x plus 5, there are two ways that I could write this. One way is I could use the distributive property. So I could do 1/2 times 3. So really that's the same as like 1 times 3, and this is 3 over 1, so 2 times 1. So we've got 3 over 2x, and then 1/2 times 5. So 1 times 5 is 5. And 2 times the invisible 1 down here is 2. So I've got 3 over 2x plus 5 over 2. The other way that we could write this is if I see a 1/2, what I can do is 1 could be multiplied by everything, which would stay the same. So I would still have 3x plus 5. And then on the denominator, I'm left with a 2. So 1 got distributed, and then 2 stayed on the denominator. So this means the same thing as this, they're just written in different ways. So I would say the green one is probably the more simplified form in my opinion, but both mean the exact same thing. So all three of these represent the same idea. So looking at it a different way, if I start with it from this manner and I want to write this using the distributive property, if I see a 3 on the bottom, I'm going to turn this into a 1/3 on the outside because 1 doesn't change the top at all, and I'm just taking the 3 out of the bottom, and I'm left with 2x minus 5. So if I distributed this, it would look like it did on the last slide. The other way you could see this is I could think of the distributive property as distributing the 3 to both of these terms. So I could think of it as 2x divided by 3, so 2x over 3. Which is the same as 2/3 x. And then you would also have to do it with the minus 5. So we would have minus 5 over 3. So this is the classic way to envision the distributive property, and you would distribute this and get the 2/3 x minus 5/3. But if you don't want to take the step into writing it this way, if you want to envision just dividing both of these terms by the 3, that'll get you to the same result as if you had pulled out the 1/3 and distributed it that way. Would that same method work on this next slide? So I've got a 3 on the top. So if I try to do that trick where I do the distributive property, I would be trying to pull the denominator out. So it would look like 1 over 2x minus 5 all times 3. So that doesn't really help me. It doesn't look like the distributive property. I couldn't distribute. And you cannot split up the denominator, so I couldn't have done this as 3 over 2x minus 3 over 5, because this denominator has to stay with the whole thing. So on this one, that idea, you can't simplify. So we're just going to say not possible, or can't simplify. It's just going to stay as it is. So looking at a few more examples, I've got this one, so I've got 10 plus 4 over 2. So you could take this out and write 1/2 times 10 plus 4, and then distribute. Or you could think about it as 10 divided by 2 is 5, plus 4 divided by 2 is 2, and 5 plus 2 is 7, which is the same thing you would have gotten if you were distributed. Here, I've got the single number on the top, and then I've got a longer expression on the bottom. So this one I cannot simplify because I cannot take 5 divided by 1 and 5 divided by 4x. So this one you can't simplify. Or you could say not possible. One more quick one like that. We've got 20x plus 12 over 4. So I could write that as 1/4 times 20x plus 12. And then if I wanted to distribute this, that would be 20 over 4x plus 12 over 4. And you should simplify this as much as you can. So 20 divided by 4 is 5x, and 12 divided by 4 is 3. It might have been faster if you just looked at it this way. So you'd see 20 divided by 4 is 5, and 12 divided by 4 is 3. Here you cannot do that same method, so this one you cannot simplify, or not possible. So now that you've looked at how to deal with fractions in the distributive property, why don't you try some practice problems?